Now that we've looked at the simple automated sperm that swim in that scene, let's look at the more complicated yellow siblings that need to be animated exactly like any character. You can't apply some kind of wave modifier to that and just move it around. You really have to think when you're animating it so it can emote and act and move around freely. So you have to animate it with an armature just like any other character. And let's see how that kind of thing is rigged in Blender. First of all, it's a lot simpler than a bipedal character with arms, legs, head, face, etc. It only has one length that gets slightly fatter at one end. And with that simple shape, it has to do a whole range of emotions and motion. If you look at the shape in the scene file, in the library file sperm.blend, you'll see that it's a simple shape on layer 2, but also that there's a lot of hidden things on that layer once again. And I can hit Alt-H here to make those hidden things visible temporarily, and we can see there's quite a lot of them. They're also unselectable, and for the purposes of this demonstration we need to click on them and make them all selectable so we can see what they do. And so let's see what we have here. First of all, we have the mesh itself, and that mesh has, as expected, a bunch of modifiers on it. The first modifier is a mirror modifier, because I just modeled one half and mirrored it. The second modifier is a lattice, followed by another lattice, and finally a subsurf to smooth the end result. The two lattices are responsible for transferring all the deformations due to the animation to the final mesh. And the lattices are linked to the objects HarpoSpoochLat and HarpoLat. I named this character Harpo after Harpo Marx from the Marx Brothers. So, let's look at the two lattices here. And in order to see what they each do, I'm actually going to use the armature and animate, or rather pose this a little bit, so we can distinguish what happens due to all the lattices and all the controls. So I'll rotate the sperm's head here, and I can even move the entire sperm with this if I want to animate it moving around in space. So I'll just rotate and rotate, and we can look at what these things do. So here we have the Spoochlat, and here we have this deformation lattice. Now it's obvious that the deformation lattice is causing the whole curve deformation of the sperm's body itself. And the way that happens is because this lattice has an armature and a curve deformer on it. Now the armature isn't doing much in this case, but the curve deform is what's giving it that shape. Now the curve is being affected by the armature itself. And if we zoom in really close, we can maybe start to find that curve. I'm going to hide the lattice temporarily. And I'm trying to find our curve. Sorry. Oh, it's right here. So there's a curve. Now the curve has a bunch of hooks on it. And these hook modifiers are simply these little empties that move the various part of the curve around. Each empty is parented to a bone in the armature, which is drawn as this little circular shape. And so moving the armature bones around allows you to move these empties directly, and thus deform the shape of the sperm. Furthermore, So that's the basic posing of the body accomplished. You can just use these little balls here and move the sperm around. That's not really enough for animation though, because it's going to be very hard to control this creature just by using a bunch of little balls. Now, as we saw with man candy, we can do FK animation, and so what I did is I created a chain of bones starting from the middle, going up to the head and to the tail, that I can animate in FK to do FK animation of the sperm. And then I can further refine that motion, for example, by clicking on these little balls and moving them around. And so that's how that's accomplished. Now if you unhide that lattice again by hitting Alt-H in object mode, we'll have a look at the armature modifier on the lattice. Notice how the lattice got thinner as I pulled this further out. That's because the lattice, before it's deformed by the curve, has an armature modifier to the armature Harpo sketch arm, which is not the same armature. This armature here has local constraints to various bones here, which allows it to squash and stretch as I pull various parts of this in and out, thus deforming the lattice shape and causing the sperm to get thinner as you pull it longer. But there's a little bit more yet, because we notice that on the mesh itself there's two lattice modifiers and not one. And one of them is to this Harpo spooch lat, which is down here. Now if you notice these little arrow shapes that are hanging around on the armature that deforms the creature, if I click one of these and move it towards the head and the tail, it causes the body of the sperm to pour into that part, squashing or stretching appropriately. And how that's done is we add this lattice modifier on the mesh, which is being deformed by this armature, and you'll see that there are local copy location constraints between the bones of this armature and these bones here that are being used to deform the sperm. And so that gives us control to have the whole weight of the sperm internally pour towards its head or towards its tail and cause some kind of extreme squash and stretch animation as we move it around. Let's hide these lattices because they're a little bit in the way, now that we saw what they did, and show some more features of this rig. Most of the animation in that scene is occurring on a vertical plane, with the camera looking sideways at this creature as it deforms. And I can accomplish quite extreme deformations, especially if I directly bend these balls here. But what happens if I bend them on the other axes? I'll click on the manipulators here, and I'll cause another extreme deformation in this axis. If we look closely at the mesh, you'll see we got some pinching right here, whereas we don't get pinching from this deformation here. We just get it from the horizontal direction. That's because the curves have a problem when they twist through their up z vector of the curve object. The fix for that is to use this manipulator here on the armature that allows twisting the curve in z and fixes these in time as they occur. Because it's a bone, you can animate that to fix the z-twist of the curve dynamically in the animation whenever you have pinching problems. And that's done simply by parenting the curve to that bone, nothing else. This bone is basically the parent of all the bones and allows you to move the entire object as one. And then there are some more niceties. If we observe these bones here, they're parented to these segments, but they're not parented directly. And I'll show that by unhiding a layer in the armature. Wrong area. So you'll see these little bones here are the parents of these balls. And these bones have copy rotation constraints to this controller over here, which cause them to spin as it spins. The reason I did this is because in my animation I wanted to do a corkscrew shape where the two sperm are swimming towards each other and corkscrewing around and then swimming through each other in that configuration. And I wanted to be able to do that whether the tail was bent or straight. And so what you can do with this setup is move these bones to create your basic corkscrew shape, which means moving alternate bones here up and down, like so, and then moving alternate bones here, left and right. So here's a basic corkscrew shape, and we can actually hold that shape even if the sperm is bent along the curvature of its spine. Like so. Now to create the spinning corkscrew effect, we can simply animate this bone, and the entire body spins around, because the parent bones that are lined up along the length of this curved chain of bones simply spins with copy local rotation to this controller, thus moving all the children spinning around that axis. And you can easily create those helix, spinning helix style animations with this character. And that concludes the rigging demonstration for this particular character. And since it's a group, it's linked into the scene file in the same way that Man Candy is.